Today on How It's Made. Plastic bottles and jars. Mail. Eggs. And handcrafted wooden pens. Whether you're buying apple juice or peanut butter, you've probably noticed that fewer products come in glass containers these days. Plastic packaging is becoming more common. Plastic bottles and jars are lighter to carry and leave no shards of glass to clean up if you drop your grocery bag. Many transparent bottles and jars are made from a type of plastic called polyethylene terephthalate, or PET. An automated mixer combines PET pellets with flakes of recycled PET. Reprocessed plastic loses some of its physical properties, so the recycled content can exceed 10%. The PET drops from the mixer into a plastic injection machine that heats it to a piping 600 degrees Fahrenheit. The dry raw material melts into thick and gooey liquid plastic. The machine then shoots it at high pressure into a mold. This plastic injection molding process casts pieces of plastic called preforms, starter shapes that subsequent machines will transform into bottles or jars. The molded preforms harden almost instantly, thanks to a built-in cooling system. These preforms are now on their way to becoming single-serving juice bottles. This is another plastic injection molding machine. It uses the same method to make preforms for a different model, 1.5 to 2 liter bottles. The preform's next stop is a machine called a reheat stretch blow molder. In a matter of seconds, it heats each preform just enough to make the plastic malleable, then inserts a rod to stretch the preform lengthwise, while at the same time blowing in air at extremely high pressure. This forces the preform into a bottle-shaped mold. Cold water circulates within the mold to cool and set the plastic almost instantly. This lightning-fast machine churns out 10,600 bottles per hour. No wonder we've had to show it to you in slow motion. A conveyor belt transports the finished bottles to the packaging area. Before blow molding, the preforms for certain models first pass through an oven. A technician sets the heat level of each infrared oven lamp individually, applying more or less heat at various points to influence the thickness and shaping of the plastic. From the oven, the preforms go into another reheat stretch blow molder that transforms them into peanut jars. It's the same process for this peanut butter jar. After molding, the machine instantly cools the plastic, locking in the shape. The factory pulls samples off the line at regular intervals for quality control testing. Technicians measure the thickness of the plastic and perform a compression test to gauge its strength. They verify the sample's dimensions and capacity. They also evaluate resistance to vacuum pressure, because containers are often vacuum sealed after filling. Some models must also be strong enough to resist the pressure of their contents. Carbonated soft drinks, for instance. The recycled material used in making these bottles and jars doesn't come from used plastic containers. For hygienic reasons, the factory recycles only new plastic left over from its manufacturing process. The finished containers, of course, are fully recyclable. They're typically reprocessed into other plastic products or into products that contain some plastic. What do the letters F, D, I, O, and U have in common? They are all part of postal codes, used in abbreviations for state names. These letters and numbers are read by high-tech machines that sort our mail. The trucks unload the containers picked up from postal outlets and bags of mail that were collected from public mailboxes. The containers go straight to automated sorting. Their contents have already been classified by size. Not so for the bags. Postal workers empty them and put standard-size envelopes on a conveyor belt leading to one sorting machine, and large envelopes into a bin destined for another. The standard-sized letters travel to a high-speed, high-tech machine that checks for postage. Stamps contain an invisible fluorescent material that illuminates under ultraviolet light. The machine's UV sensor scans both sides of every envelope. No glow, no go. Letters with postage are canceled with a postmark so the stamps can't be reused. The postal mark contains the date, the state, and the sorting plant's postal code. Next up, a machine called the Multi-Line Optical Character Reader. An impressive piece of equipment that processes up to 30,000 letters per hour. It reads and digitally photographs each destination address, matching it to the computer's address database. Then it prints the postal code in barcode format on the front of the envelope. A scanner now reads the barcodes and does the preliminary sorting. Local and regional mail stays here and moves on to the next sorting machine for a more detailed breakdown. Letters addressed to other regions go to the postal plants there, where a thorough sorting will take place. But what happens when all this sophisticated technology just can't make out the address due to, say, sloppy handwriting or smudged ink? The optical character reader machine puts the letter on hold and sends the address photo to the video encoding system. A postal worker deciphers the writing and types in the postal code, sending the letter back into the sorting system. Now, the local and regional mail goes through what's called the BCS, the barcode sorter. This performs a more detailed sorting by postal route. The machine scans the barcodes at a rate of 30,000 letters per hour, sending the mail to the corresponding letter carrier's bin. A worker preps the mail for each route, grouping and labeling it by sector. Meanwhile, the large envelopes go through what's called the flat sorting machine. It does what 3 machines did for the standard size letters. Postmarks the stamp, reads the address, applies a barcode sticker, reads the barcode, sorts the mail, and drops it into the corresponding letter carrier's bin. If the machine can't make out an address, the envelope goes for manual sorting. In manual sorting, postal workers handle more than just illegible addresses. They also hand-sort mail going out of country, and envelopes that are too thick or bulky to go through the automated machines. At all stages of mail processing and delivery, Workers are on the lookout for envelopes bearing insufficient postage. Those letters are returned to sender. Letter carriers sort the mail for their routes by street and house number. If they have a walking route, they load up their first bagful and head off. A truck delivers the rest to a locked box along the route, called a relay box. Carriers pick up the rest of their mail when they pass by it. Some letter carriers have what's called a motorized route. They deliver all their customers' mail by truck, which sure beats walking door to door in a blizzard. Hens don't have to mate to lay eggs, and as long as there's no rooster in the vicinity, the eggs will remain unfertilized and edible. The color of the shell is determined by the breed of hen, but there's no pecking order when it comes to shell color. White or brown, all eggs are the same inside. The action begins in the hen house, where female chickens start laying eggs when they're 19 weeks old. The building is well ventilated, and the temperature and humidity are strictly controlled. To stimulate laying, fluorescent lighting simulates 15 hours of daylight. The hens eat a measured amount of food 3 times a day. Their feed is made up of various grains mixed with soybeans for protein. It's fortified with vitamins and minerals and contains calcium to strengthen the eggshells. The hens drink water from nipple-ended tubes attached to their cages. All these carefully monitored conditions are designed to maximize the yield. The average hen lays about 300 eggs a year. The cage floor is sloped, so the eggs automatically roll onto a conveyor belt. Then it's onto a larger conveyor belt which transports the eggs to the packing room. The hen's manure drops through the bottom of their cages onto a conveyor below. Even so, some eggs get dirty. They'll be thoroughly cleaned and disinfected later on. Automated equipment transfers the eggs onto plastic flats. It places them wide end up to keep the yolks properly centered. The flats go into a cold room until a refrigerated truck ships them to the grading station, whose job is to classify the eggs by quality. The best, grade A, end up on supermarket shelves. Lesser grades go to processing plants to be turned into ingredients used in foods, pharmaceuticals, and products such as shampoos. This automated station is high-tech and high-speed, processing 144,000 eggs per hour. First, a suction machine lifts the eggs off the flats and transfers them onto a moving track leading to the cleaning station. There, a washer gently scrubs the eggs with soap and disinfectant. The water is just over 100 degrees Fahrenheit. Anything hotter would cook the eggs. Then it's into a dryer for 5 seconds, where a fan sucks up the moisture. The eggs then pass over a bright light, which highlights the condition of the shells. Workers do a preliminary visual inspection, removing any that are cracked. A grading camera above assesses the condition and quality of the shell's exterior. Further down the line, other cameras will inspect the interior for blood. To check the strength of the eggshells, acoustic sensors tap on the eggs. They detect brittle shells by the different sound of the tap. The inspection machines mark and reject any egg that doesn't make the grade. Grade A, that is. The approved eggs move on to electronic scales, which register their weight class from peewee to jumbo. Pressure-controlled claws then transport them to the corresponding packaging line. On the way, every egg gets stamped with a lot number for quality control tracking. The packing machine stamps the egg cartons with the best before date. The eggs have a shelf life of 35 days. As for the hens, their expiration date comes at 72 weeks, when the eggs they lay are no longer consumption quality. For all their hard work, they win an all-expenses-paid trip to the slaughterhouse. A pen set is a classic gift for any occasion, be it a birthday, graduation, or promotion. We're not talking pens of the inexpensive ballpoint variety, but rather those Cadillac models in sleek metal or sumptuous wood. The quill dates back to about 700 AD. Made from a bird feather, its tip had to be repeatedly dipped in ink. Messy and inefficient, the quill remained the norm for more than 1,000 years. In 1884, an American invented the fountain pen, with its built-in refillable ink barrel. But the true revolution came with the no-fuss ballpoint pen patented by two Hungarian brothers in 1938. Handcrafted wooden pens can be made from just one type of wood or from a combination of woods. This artisan uses some 50 different kinds, ranging from domestic maple and oak to imported rosewood, ebony, olive wood, and purple heart. When using just one type of wood, he runs the block through a bandsaw, cutting a strip 6/10 of an inch wide. Then, with the radial saw, he cuts that strip into two pieces, each about 2 inches long. These will become the pen's top and bottom casings. Using a tool called a drill press, he bores a hole roughly 3/10 of an inch in diameter right through each piece. Making a pen from a combination of woods takes a little more work. Instead of using a block of solid wood, he constructs a block by gluing together thin planks of contrasting woods. Once the glue dries, he uses a wood planer to remove the excess and smooth out the sides. Then, just as he did for the single wood pen, he cuts the block into strips 6/10 of an inch wide. This time he slices diagonally, so that each strip showcases the multiple woods. Again, he cuts pieces for the top and bottom casings, then drills a hole through them. From this point on, whether he's using one or more woods, the process is the same. He coats two brass tubes with glue and inserts one in each casing. A few drops of water are added to expand the adhesive into any gaps between the tube and surrounding wood. These brass tubes will house the pen's mechanism. The glue takes about an hour to dry. Then he uses what's called a hand mill to square all the angles and remove the excess glue. Now for the artistic part. He turns the casings on a lathe to shape them. First, he rounds them out. Then, using a series of tools, he gives each casing unique detailing. He highlights the grooves by using the heat that friction generates to burn them dark. When the design work's done, he runs sanding cord inside the grooves. Then he sands the surface 3 times with progressively finer sandpaper. To protect the wood, he varnishes the casings with 4 coats of hardwood floor varnish, sanding between each application. When the last coat dries, he can assemble the pen starting with the tip. He glues it to the bottom casing, tapping it with a mallet to ensure it's fully inserted. The tip is made of titanium, a very resilient metal. Next comes the clip, also made of titanium. He glues it into the top casing. Finally, using a vise, he forces in the pen's mechanism. The mechanism houses a replaceable ink cartridge. A titanium ring joins the 2 casings. As an added touch, the pen can be personalized with an engraved clip. And the gift box can bear the recipient